What does a banana peel and a phone charger have in common? One is ready to rust, the other is ready to recharge. But what if I told you that this banana peel could help create electricity, like real electricity? Today on Science Unlocked, I want to find out how trash gets turned into electricity right here in Ghana. Ghana produces over 12,000 tons of solid waste every day. That's like throwing away the weight of 2,000 elephants every single day. And the truth is, there are not enough systems to manage it all. Only about 10% of Ghana's waste is properly collected and processed. The rest ends up in drains, gutters, landfills, or they get burned up in the open air. Open burning is one of the most common ways people deal with waste, especially in urban areas. But it's dangerous. It releases toxic chemicals, it damages the air quality, and it affects public health. But here's what's wild. 49 to 68% of all the waste that is thrown away is organic. Food waste, plant matter, things that break down. And all of that could actually be turned into energy. Okay, so I brought some leftover rice. I have here banana peel, I have some paper here, and I also have this nylon bag. I'm super excited to see if my garbage actually makes it into the system. So let's go find out what happens to this stuff and meet the team that turns waste into electricity. Okay, so why is this important?
This is a protective gear, just to protect the environment.
So now we're at the sorting stage, right? So can you walk me through the process? What goes on here?
The waste we saw there is heterogeneous. We saw a lot of, there's organic, there's plastic, there's paper and all that. So it comes in and then it goes to the blue barrel you see there.
Yeah, what exactly are we looking out for here?
The first point, which is where we tip the waste into the hopper, is just to be able to have them rolling on the conveyor belts. So our sister here wants to enjoy what you're enjoying.
I want to join you.
Right. Don't be scared. So okay, you can get closer to him and then maybe trap this one.
This one?
Yeah.
Okay.
So that was easy, right?
Trash doesn't just pile up here, it powers up. At the waste-to-energy plant, waste takes on a second life. First, it's sorted. The organics go one way, the plastics another. The lightweight sachets and bottles you toss aside, well, they are washed, shredded, and reborn as pellets or tightly packed bales that fuel furnaces and factories. But the real alchemy happens next. Inside giant oxygen-free chambers, plastics are heated to 700 degrees Celsius in a process called pyrolysis. The result? Not smoke, but plastic oil. This high-energy fuel can power generators today and maybe vehicles tomorrow. From rubbish to resource, Ghana is turning waste into what and rewriting the future of clean energy one plastic bag at a time.
This stockpile here is from the sorting that we've done.
Okay.
That's organic recovery from the municipal solid waste.
Okay.
Right. We have another fraction of waste, which is waste sorted at site.
Okay. So that's what we have here.
Sorted at site. So as part of our methods to get waste, which has already been pre-sorted at site, we have this program where we send dustbins into restaurants in town.
Okay.
And then we have educated them on the importance of waste sorting, the detrimental effects of littering around and all that. So from time to time we combine these matrices of waste and then we process them to make the biogas. And then the process continues. What you can see him doing is feeding in the waste into the shredder. Particle size reduction is very important.
Why?
See, the process of producing biogas is biochemical and there are stages. The first stage is called hydrolysis. At this stage is considered as the rate limiting stage. What it means is that it is the most difficult stage to get over.
Okay.
It is mostly done by microbes using their enzymes, but then we can also introduce a human intervention to make it easier for the microbes.
What's the human intervention?
Human intervention is mechanical methods like the shredding. So the shredder is a mechanical component. So we introduce the waste in the shredder, breaks it down.
So I'll follow your lead.
Into that.
That was a lot of that was a lot of work.
It's a lot of work, eh?
How long does this whole process take?
The feeding, we can be done in 30 to 45 minutes.
Sorry, at this point, what are we looking out for? Because I don't really see any plastics.
Right, this waste that came from source was properly sorted. Or the people we gave the bins to listen to our message. Which message was that please put in only organic waste into this bin, right?
Yeah.
Inorganics are to be placed in the other bins. So what we are seeing speaks to the fact that they really listen to us, and I think it's a step in the right direction. If we can get lots of campaigns like this, teaching people how to sort waste.
So from this, what do we do next?
So from this shredding, it goes into another shredding
Process.
phase.
Okay. Okay.
Now this is where wet grinding happens.
Okay.
So you can see the interconnected pipes. Water flows through it, through the tank we have there. And then as the feed goes into this chamber, it is mixed with water. And then it flows through this tunnel into our settling tanks, which is the next phase.
Is this method similar to composting, or are they completely different things?
Biogas is a mixture of gas that is produced when microorganisms decompose organic materials in an anaerobic condition. So the microorganisms that are involved in biogas production do not require oxygen in their metabolism, right? As opposed to composting, which is an aerobic process. Based on this, designing the systems for biogas generation and composting would have to be different. For biogas production, the system would have to be airtight. For composting, in fact, you would have to find a way to infuse oxygen into the composting part so that the process goes on as expected.
So from here, what happens next? Where does this liquid go?
Yeah. So from here, we have a slurry, right?
Okay.
So,
Thank you.
right. So from here, we have the digestion slurry.
Okay.
And then it gets to this point where we have these two tanks. You can see this tank.
Yeah.
And then there's another one in front of us. From that tank is where we finally pump the material into the digester.
So please walk me through this. What's happening here?
So this giant you see here is our biodigester.
Okay.
It is 1,000 cubic meter capacity digester.
Okay.
It is an airtight system, right? Because the system to produce biogas is anaerobic. The microorganisms involved do not function so well in the presence of oxygen. So we will go now and then see the gas. We open a valve and then the gas would flow through the pipe, and then we'll measure the quality
of the gas. Wow.
Right?
Okay.
So this is the line through which the gas flows.
Okay.
Right, and then it continues into our purification room.
Okay.
And then finally into the generator, where it's converted into electricity. So what he's doing now is that he's checking the quality of the gas that we have produced, right? So if you can see what we have here, so you can see CO2.
Yes.
That's carbon dioxide.
Okay.
You can see CH4, which is methane gas.
Yes.
Remember I said the quality of biogas is based on the methane percentage. If you produce biogas and the methane percentage is above 50, 55, you've done a good job.
Okay, so we have done a good job.
We have done an excellent job.
We have done a good job.
So just as home, if we have our gas compressed in our cylinders, we flame it and then we cook with it.
Yeah.
Right? It is exactly the same as this.
So you can actually cook with it?
Yes. Yes.
Wow. So do you use this gas here to cook?
No, we don't.
We
only channel it into electricity.
Okay, but like if you wanted to use it to cook, you can actually use it to cook.
Could, yes. Mostly biogas is saturated with water. All this would have to be reduced or ideally eliminated. So the gas will now go through a purification system.
Okay.
Let's talk more about it.
So if we are able to extend such a project to other regions in the country, it's going to send the message clear out there that waste is really value. Every power we use here is from waste, right? And it's marvelous. So if we can be able to replicate this project in the other regions in the country, it will send a rippling effect to the other African countries So if we get a little push in terms of the support, right, and then also we that are actively in the industry, if you're able to play our cards well, if you're able to talk to the local populace, get them conscientized about the whole waste management. I mean, if you couple all of these things, I believe that the way we view waste here in Ghana, by extension, it will go to Africa, and then collectively we all would contribute to, you know, the global fight against the climate, you know, related issues and all that. So yes, this project really has a huge impact.
Okay, so we did a lot of work today, and I say we because I did a lot. I did a lot of work. I was part of the sorting team.
Yeah, you were.
I was part of the filtering. I carried a shovel and I put in some of the organic waste
Right.
into the grinder, and I think it's about time that we test this waste, that we test the gas. Sorry.
Right.
We test the gas. So I have my phone here. It's a bit low and I'm willing to charge it with our hard work of today and the gas that we have produced. So let's see if my phone would actually charge. So we brought our trash, we sorted it, we grinded it, we fed it some bacteria, and now we have our gas, real usable electricity. I hope you learned as much as I did in this series, Science Unlocked. I will see you again next time with some brilliant, messy science for us to dig into. Until then, bye.